Guys, this is Mrs. Upmore. We're going to talk about dimensional analysis today. So a couple of background pieces of information that are important are that we will only be using the metric system in physics. The metric system is actually used across the world in science, and so that's why we'll use that in physics. Secondly, and this is kind of cool, the metric system is a decimal system. So basically that just means that we will not be using fractions. And then anytime you have an equation or a number that looks like a fraction, you need to go ahead and divide it out to get a decimal. For example, if you look in the notes here, 38.7 miles per hour is not very meaningful to us. However, 5.4 miles per hour is a number that we would be familiar with and that we could use. So the metric system helps us describe things that are very, very tiny, like a single electron, all the way up to things that are really, really large, like the size of the whole universe. And we will actually be looking at some very small numbers, like electrons, and some very large numbers, like distance between the Earth and the Sun in this class. For the most part, we'll use centi, milli, micro, and nano quite often. And then on the small side, on the large side, we'll be using kilo, mega, and giga. You can see, of course, that the numbers can get larger and they can get smaller, but those are pretty much what we'll use in physics. I did want to show you what your conversion sheet looks like. You can access this on Canvas. You can print yourself a copy if you'd like. You'll have access to it on all quizzes, tests, homework checks where you would need to convert something. So let's take a look at it. Up here at the top, you've got conversion factors. So let's say that we're back in person and you are measuring something in a lab and you forget that we're in the metric system and you use inches. Well, instead of having to fix that, to figure out how many, or to remeasure, you actually can find the conversion right here. So you can go from inches to centimeters. You can go from feet to meters. You can go from miles to meters. So if you've got a non-metric measurement, you can easily convert it using this sheet. You've also got mass, you've got time conversions. Eventually we'll start talking about things like weight and forces. So you've got lots up here at the top. And then on the bottom of the page, you've got a long list of all of the conversion factors. So if you look in the center here, it says 1 meter, 1 meter. Okay, so that's your base. That's your kind of your standard measurement. Everything above that is going to be larger. Everything below that is going to be smaller. So visually that will help you figure out. The meter is what we use the most often in physics, and so that's the examples. All of the examples given are in meters, but you can use this chart for grams, for liters, for any kind of measurement that is in the metric system. Okay, so if you see a letter and you're not sure what it is, you've got a column for symbols, you've got the prefix spelled out for you, and then you've got the factors or the exponents. If you are really good at using those factors, you already know how. I would encourage you to keep doing that. If not, you're going to learn in this class. Basically, it's representing the number of zeros in the numbers. Probably the easiest way to think about it. We'll come back to that in more detail later down the road. So if you're not comfortable, don't worry about it for now. If you are, by all means, go ahead and use it. Okay, and then example 1 column and example 2 column are basically two ways of looking at the conversion. So notice in example 1, it compares all of the prefixes to 1 meter. Okay, so how many of the prefix would be in 1 meter? Example 2 compares how many meters would be in the exponent. Figure out how to do that. Sorry guys, I'm new to using Notability. Okay, so you can use either column 1 or column 2. I would encourage you to probably not go back and forth. And I'll show you some examples for what I mean by using the columns. But you can see that you don't need to memorize any conversions at all. They're all listed for you. You have them available to look up. So get familiar with this page. Okay, so conversions is basically taking one unit in the metric system and turning it into a different unit in the metric system. It allows us to compare easily. And so for example, if you look here, if we compare 1,200 centimeters to 0.43 hectometers, and we want to know which one is bigger, that's a really hard question because centimeters and hectometers don't compare easily. That's hard to do in your head, okay? So what we can do is convert both of those to meters and then compare. Okay, so if I'm going to convert 1,200 centimeters, I'm going to draw myself a little set of boxes here, like this. I want to get rid of centimeters. I want meters. Now let's say I don't remember how many centimeters are in a meter. I'm going to go back to my chart. I'm going to find centi, which is here, and I see that in 1 meter there are 100 centimeters. So I'm going to put a 1 here. I'm going to put a 100 by the centimeters. I'm going to multiply everything on top. I'm going to divide by everything on bottom. I'm going to double check and make sure that my units cancel. I have 1,200 times 1 divided by 100, so that gives me 12 meters. Okay, and then I'm going to do the same thing with hectometers. So I start with the given number, 0.43 hectometers. And then I go up to my chart and I find hecto. And I see here that 1 meter is equal to 0.01 hectometers. Okay, so 0.01 hectometers is equal to 1 meter. I put hecto on the bottom here because I want them to cancel like in math class. I'm going to multiply on top. I divide by what's on bottom, and I end up with 43 meters. 0.43 divided by 0.01. So when I do that, when I have them both in meters, I can easily compare and see, oh, the hectometers is larger. Okay, so we convert so that we can easily compare numbers. We measure a lot of stuff in physics, and we need the ability to quickly compare, and so we will use conversions to do that. There are a couple of different methods. If you learn the King-Henry method in chemistry or biology or some prior class, and you're good at doing that, that's the method where you're moving the decimal a certain amount of places, you're welcome to do that. I have found over the years that a lot of people really struggle with that because they don't know whether to move the decimal to the left or to the right. So if that's you, I would strongly suggest just forgetting that you ever heard about King-Henry and doing what we call dimensional analysis. If you are good at using it, you can, but notice that it begins on kilo and ends on milli. And we talked about up here that we go beyond kilo, right, mega and giga, and we go beyond milli, below milli to micro and nano. So there are times when you will have to use this dimensional analysis. You won't be able to do King-Henry. So we're going to learn it now, and we're going to get really, really good at it. Okay, so dimensional analysis is basically converting using the boxes that I just showed in the example above. So, for example, you want to convert 78 minutes into hours. In the very first box, you're going to put what was given, okay? And then you're going to forget about numbers, and you're just going to think about units. So I want to get rid of minutes. So thinking like in a math class, if I want to cancel that out, it needs to go diagonally across from the original. And then I want hours. Okay, and then I'm going to think how many minutes are in an hour. In 1 hour, I have 60 minutes. Generally, everybody knows that one, but if you don't, it's actually on your conversion sheet. And then I'm going to check and make sure the units I don't want cancel. I'm going to make sure that I'm left with the unit that I did want, and I'm in good shape here. So now I multiply across, I divide by what's on the bottom, and I see that 78 times 1 divided by 60 is 1.3 hours. Okay, so that's all dimensional analysis is. It can certainly get more complicated, and we'll look at some that are more complicated coming up. But basically, It's really, really helpful, especially if you don't know which way to move the decimal, because you're multiplying and dividing and you're lining things up using the units and your conversion factor sheet. So you don't have to guess, you don't have to wonder which way to move. Okay, so let's keep going. The examples in the notes. Let me get a brighter color here. So 3,000 centigrams. I would encourage you to pause the video right now and try this on your own, see if you can get the right answer. So if you are continuing to listen or you're tuning back in, I want to get rid of centigrams and I want grams. Okay, so then I go look at my conversion sheet and I see that by centi I can see that there's 1 of the base and 100 of the centi. And so then I'm going to check and my units cancel. I'm left with the unit that I wanted, which was grams. So I'm going to multiply across and divide by what's on the bottom, and I end up with 30 grams. Next problem. Something funky happened to my equal sign here. So I want to change 5,200 meters per second into kilometers per second. So notice here, this is a little bit more complicated because we have 2 different units. Okay, so first things first, the way that you write this is 5,200 meters per second. This is like saying I can go 5,200 meters in 1 second. Think about like miles per hour. 30 miles per hour means I could go 30 miles in 1 hour. Okay, so I'm just taking this unit that we've written in shorthand and breaking it up here in my boxes. Okay, so I want to get rid of meters and I want to get kilometers. So I'm going to put meters down here. I'm going to put kilometers here. And then I'm going to go look at my conversion sheet and I see that in 1 kilometer there are 1,000 meters. I'm going to double check, and seconds here is the same as seconds here, so I don't have to mess with that. I'm going to cancel meters, and then I'm going to check and make sure that my final unit will match the one that I am supposed to be getting. So kilometers is on top, like it is in the answer, and seconds is on bottom, like it is in the answer. So I'm in good shape here. I know I've set this up correctly. Okay, so now I go multiply across, I divide by what's on bottom. So ultimately this is 5,200 divided by 1,000, and that gives me 5.2 kilometers per second. Remember, in physics, this unit is equally important as the number. Okay, so let's try another one that's got a 2-part. And again, I would encourage you to pause the video and try this and then come back and see the answer. Okay, so if I set it up, 28 beats per second. Okay, and then I want to get beats per minute. Remember, this per is like saying in 1. And so if you need to put that 1 here just to kind of make it make sense, that's fine. Okay, if I look at the conversion that I want, I still want beats, so I don't need to mess with the top unit. However, I'm trying to get minutes instead of seconds. So let's think about if I'm canceling seconds, where do I need to put seconds in order to cancel it? Well, same rule applies, even though it looks weird. If they're diagonally, they cancel, and so I want seconds up here so that it will cancel what's down here. Okay, then I'm trying to get minutes, so I'm going to put that down here. In 1 minute, I have 60 seconds. So always do your units first and then add in your numbers so that you are able to figure out where to put the numbers. Okay, I check and I make sure seconds cancel. I'm left with beats on top, minutes on bottom, and that works with what I was given here, beats on top, minutes on bottom. So I have set this up correctly. So I'm going to do 20 times 60 divided by 1, and that gives me 1,680 beats per minute. Okay, hopefully this is making sense. So we are now ready for the last one. I went ahead and wrote it because my PowerPoint didn't transfer, but this should be the same as what's on your page. So 95 miles per hour into meters per second. So this one is a little tougher because we're changing miles here to meters and hours to seconds. We've got a two-part conversion here. The conversion factors are given to you on the page. They're also on that conversion sheet, so you don't have to memorize this. And there are a couple ways to do this. First way is to go ahead and set up your number, 95 miles per hour. Okay. Actually, I'm going to color code a little bit because I'm changing both here. So I'm going to put what's on the bottom in green. Okay, so miles per hour is like saying I can go 95 miles in 1 hour. So mph here is going to break up like that. Okay, and then I'm going to convert just one thing at a time. So right now I'm just going to focus on what I wrote in black ink. So I want to get rid of miles and I want to get meters. Be real careful that your miles and your meters look different. Don't use an M for both or it gets real confusing. Okay, then I go look at my conversion factor and I see that in 1 mile, I have 1,609 meters. Okay, I check and miles is canceled and I have meters on the top, which is where it is in what I'm looking for. Okay, now I'm going to ignore everything in black writing and I'm going to look at converting the hours, so the green writing now. Okay, so I have 1 hour on the bottom here. So in order to cancel it, I'm going to put it on the top. And then I want seconds ultimately. You can actually go to minutes down here if you want and then make yourself another box. But I'm going to go straight from hours to seconds because I have this conversion here that tells me in 1 hour I have 3,600 seconds. If you were going to do the minutes, you'd put 1 hour here, 60 minutes here, and then you'd have to make yourself another set of boxes where you say 1 minute or 60 seconds. And that works too. It's really whichever makes the most sense to you. Okay. So let's check here. Hours and hours are across from each other, so they will cancel. I'm left with seconds on the bottom, which is where I wanted it. So I know I have set this up correctly. So now I'm going to do 95 times 1,609 times 1 divided by 3,600, and I get 42.5 meters per second. And that is my answer. Okay, if it is confusing to you to do it all in one big chart like this, you can actually split it up a little bit. So you can do 95 miles into meters. And so 95 times 1609 is 52,855 meters. Forgot to cancel that out. Okay, and then separately, I'm going to do 1 hour. And I want seconds, so in 1 hour, I have 3,600 seconds. And so hours cancel. That gives me 1 times 3,600. Okay, and then I think about how do I want my units to be ultimately. I want meters on top and seconds on the bottom. So I'm going to take my answers here. I'm going to take this one. I'm going to take this one and divide them in that specific order. So 52,855 meters over 3,600 seconds. I will not leave it in this format because, again, the metric system uses decimals and not fractions. I want to go ahead and divide it out, and when I do that, I get 42.5 meters per second. So either way is totally fine, whatever makes more sense to you. Hopefully that helps on dimensional analysis. Please try the homework before you do the homework check, and please ask your teacher if you are struggling.